All right. Hey, everybody. Welcome to COM322. This is why vibe coding isn't enough and how to build secure AI applications that scale. So thanks, everybody, for coming. OK. So you know the drill. I want to build an app that lets me talk to my documents. And I want to be able to upload these PDFs and talk to them. So I'm just going to be thinking for a little bit. And it looks pretty cool. So now we can drag and drop files that'll upload right to our application. So it's pretty sweet. But I want a list of my documents. I want to be able to see the most recent ones. So can we add that? So it's going to think for a little bit more. And now we have a list of our documents. So this is all ordered. It has all the data about it. Pretty cool. Now, what about a list of my most recent conversations? So I want to be talking to these documents. I want to have some data. I want to be able to track all that. It's going to be thinking a little bit more. And now it comes out with this. So it's pretty slick, being able to just have all these chat histories right in my app. Now, this is a cybersecurity conference, right? So we need authentication and authorization. So let's add a login. It's going to think for a bit. Got a login page. Now, one last question. Can we add an analytics dashboard, make it more visual, make the UI pop? It's going to think for a bit. I got a dashboard. So kind of cool. It's a graph. You can go over it. It looks really fun. OK, last question. Can we make a cool landing page? I feel like this could scale to millions of users. And I want to go to market with this tomorrow. It's going to be thinking a little bit more. And now we've got a vibe-coded app that's ready for prime time, right? Not quite. So there's going to be a lot of problems with this app that you would never know about. You would never know that these problems occur. It's one of those if you know, you know. Do we have zero trust architecture? Probably not. Do we have insecure dependencies? We probably do. DDoS and attack protections for spam and bots? Probably not. Rate limits and spam? No. We have poor scalability design patterns. No authentication, no authorization, or it's probably very low. And if users upload malware, is that going to attack the rest of the application? There's a lot of problems that come from vibe-coded applications that you'd never know about unless you built it. And this is the number one question that I always encourage anyone to build, is that are you prepared for 1 million users? You should always build something and think about the maximum amount of impact that you could have from it. I always get excited about building. I'm a self-taught engineer. So I always think about, how many people could this impact? So you want to think about this. You don't want to think about building an app for 10 users. You want to build an app for 1 million people. So how do we think about that? How do we build for that? So my name is Brian Huff. I am an AWS DevTools hero. I used to be an AWS community builder. And I'm a full-stack software engineer. But I didn't actually go to school for this. I got excited about tech. And I ended up teaching myself over the pandemic how to learn how to code. And I love empowering other people to build software. But we're going to get into the nitty-gritty today of how to actually productionize vibe-coded workloads. So it's going to be building apps the hard way. So I always encourage people of if something feels intimidating, it might be a little bit confusing, but I tell you it's possible. And it's really fun to be able to build apps like this. So agenda for today. We're going to enter the vibe code era. So we are in this era. We have to acknowledge that we are in the era of vibes. So to deal with this, we're going to learn how to shift development left. And I learned a concept last year about shifting security left. But I want us to even think more about how to shift development left. We're then going to build a real GenAI application, kind of like what you just saw earlier. And then we're going to build a playbook so that you can go to production with this type of workload. So this is what we're going to talk about over the course of today. So we're going to enter the vibe coding era. So what does that look like? So we're building software. We're going really fast. So we're doing zero-shot prompts. We're using the tools and technologies, all the cool stuff. We're doing upfront planning, and then GenAI low-code, no-code stuff, right? So prompt deploy, this is the strategy. And you just prompt deploy recursively until you get the app that you want. So that's kind of how vibe coding works. Now, there's going to be about 4 of these types of tools that you might use or you might work with. So the invisible infrastructure is I don't want to think about servers. I don't want to think about all the complicated stuff. Help me build my system. Then you have the GenAI builders that are I want you to build the complicated stuff so that I don't have to. The plug-and-play backends, you might just need auth, you might need data, you might need functions, you might need certain usability patterns. So you can just integrate that into your app. And then the low-code, no-code builders, those are the fun ones. That's what we're going to talk about. So that's where it's prompt, build an application, and make it work. Now, the vibe coding pipeline is prompt and then deploy. You probably already know this, but it's important to think about. What I want us to think about is shifting development left. So what that means is that it might start with a prompt. We're in the vibe coding era, so we have to acknowledge that like things might start off as a prompt. But it doesn't have to end at the prompt. We want to do scanning over all of the code that it generates. We want to then go and build. That's really important because we want to take the prompt, turn it into an actual architecture and build it. We want to automate some of these processes so it's all programmatic, it's all deterministic, it's not expected to chance. We want to review our code before it reaches our users, right? We want to test stuff, and then we deploy. So you can see that there is quite a lot of steps that can happen that prompting ignores. And it ignores it because it tries to make it easy. But building these types of softwares shouldn't be that easy. We want tools to help us with these patterns. So how do we productionize the vibes? So that's what we're going to talk about. So these are all different patterns that I'm sure you all know about. Authentication, API, using LLMs. This is not new to all of you, I know that. But how do you take that and turn that into a productionized workload? This is going to be the stack of tools that from AWS can really help you a lot. So Cognito for authentication, AppSync for API, API Gateway if you want to do streaming, S3 for file storage, Bedrock for LLMs. Then it gets fun. So if you want to distribute this workload, we're going to containerize our applications. We're going to put it on EKS, which is a Kubernetes orchestrator. We're then going to put that in front of CloudFront or behind CloudFront so we can distribute our application to more people. DynamoDB for a fast readable database, and then Amazon OpenSearch Service for our vector DB. So all these parts are going to work together. We're going to see how to build a software with all of this together. This is the builder's toolkit that helps me a lot. And I really build just with Python and TypeScript. GraphQL, if you're building APIs, it's really great to be able to just make queries, mutations, all that stuff. Then Docker, Kubernetes, and AWS CDK. If you can master these types of frameworks and these programming languages, you can build 80 to 90% of all software. So that's kind of where it kind of starts with just this. You can build a lot of stuff from it. So this is the big question that we have to first of all ask. Is our application secure? So we're going to start off with the front end. That's what we downloaded from our vibe-coded app. So GenAI can lead to a lot of bloat. If you've ever used GenAI platforms, they're going to install a whole bunch of packages, a whole bunch of code you probably don't need. They're probably using outdated packages. And if you do npm audit and actually see what it did, it might create an app with a lot of vulnerability. So this one has 6, but you might have one that has more. So you would never know this. This app is fine. You'd be able to actually put that on the web, but you shouldn't, because you're going to be exposing users to a lot of vulnerabilities. That list of 6 might become 10 or 20 down the road. So securing the app, this is why we need to get rid of the bloat. We need to get out of the outdated packages. So how do we do that? So we're going to use Amazon Q. And this is actually a real use case. This is real stuff that I did, and I thought it was really cool. So this is the Amazon Q VS Code extension. If you open it up and you go to the package.json, you can actually do that, and that's on the right. You can send it to prompt. And I actually took this, and I asked Q, and I said, hey, there's these 6 vulnerabilities. Can you help me address them? It was able to then take all of the updates that were needed, and it returned basically no vulnerabilities. So I was able to basically take 6 vulnerabilities and then turn that to 0 just by doing that one thing. Super, super simple, but it was really easy because I've worked with you migrate up to this, you update something, and then now you have to do npm, force fix and all that stuff. So you don't need to do that. It just updated it for me. So really easy way to just add security. Now we want to make sure that the infrastructure is scalable and that we can build and then deploy that. So now we're going to go to the back end. So if you've ever used CDK, or maybe you haven't, it's really easy to get started. You could use Python or TypeScript. I use Python for this as an example. So you're going to do CDK init app. You're then going to activate the virtual environment, and then you're going to install all the dependencies. So this is just an easy way to just get started building the repository for your backend. Now this is a CDK template. So that's the virtual environment that we're going to activate. All of our stacks are going to go in here. So if you see me say CDK deploy something, that file is going to live in there. Then we have the test framework. We have the app entry point. We're going to import all of those stacks into the app.py file, and that's where we'll be able to do CDK deploy X. Then configuration and metadata, dependency management, helper scripts. You don't need to really worry about those other things. It's mainly app, and then the main stack definition folder. So this is basically how to get started with the CDK. So you're going to CDK bootstrap your environment. You're going to, and that needs to happen per account that you deploy to. It just needs to happen once. And then you synthesize the AWS CloudFormation template with CDK synth, and then you're going to do CDK deploy. I have CDK bootstrap down there just to remind you that if you do ever try to do CDK deploy and it doesn't work, it's probably because you didn't do CDK bootstrap. So that's why it's there. But then after that, you're going to do CDK deploy. This is basically our app. We want our user that's authenticated to talk to our app build, and then the app build is able to talk to our Fast API server. So we're using Next.js for the app, Fast API for the server, both of those distributed through Kubernetes. That's what it looks like, and this is just a part of it, and that's kind of where there's like a lot happening behind the scenes. So we're going to walk through all these parts, and it'll seem a little less intimidating. But that's kind of where you have multiple EKS clusters that can talk to each other, and there's a lot going on. So let's deploy the app. We want to start off, we have our front-end application, and it looks really cool. It's our Talk with Documents app. We're going to put that on Amazon ECR, which is the container registry. And it's really easy. You just create a Docker file that looks like this, and then you could build it either with a CI/CD pipeline, or you could just do it locally. If you do it with a CI/CD pipeline, you're just going to need that IAM OIDC role, and then that will auto-build it. Once that's in a container and that's in the cloud, we can now take that container and put it on EKS. So EKS with CDK makes it so easy. You can literally define on the right, say like line 14, you can do max availability zones is 2. That creates resilient architecture like what you'd expect. You can provision everything within a single VPC, lock it all down. So CDK makes that super easy. So you don't need to worry about all these other configurations. CDK will just do that for you. So we're going to then add a load balancer. So that's going to help us fan out when users are trying to get requests to our server, or our app is talking to our server. We want to make sure that things don't crash and that it can expand. So CDK handles all of the IAM stuff, adds the load balancer in there, and just kind of configures everything for you. It makes it really easy. So what we're basically going to have is we're going to do CDK deploy EKS stack. That's going to create EKS. That's going to create availability zone number 1. That's going to create availability zone number 2. And inside of that, we have EC2, and that's going to help deploy our service workers with the Kubernetes pods. Then we're going to add elastic load balancing there, and then this is distributed completely through CDK. So we just update CDK, we'll update the stack, makes it super easy for us to get started with Kubernetes. So do we need a CDN? And the answer is yes, because the load balancer is just going to do HTTP, but we want to do HTTPS, we want to do SSL termination, we want to do DDoS protections, we want to add WAF. There's going to be a lot of things that the content distribution network will be able to help us with. So that's CloudFront. So why this is cool is that we already deployed the EKS stack. We can take the outputs from the EKS stack. So some of that stuff might be like the DNS, or you might store some things in parameter store. But you can take the outputs of that stack, put it into the CloudFront stack. So we talked about having like multiple stacks. And then the outputs of one become the inputs of another one. And then we're able to deploy our CloudFront distribution. So what this is going to look like is we're going to do CDK deploy CloudFront stack. We're going to add a CloudFront distribution. And now we can add Shield, we can add WAF, we can start productionizing and packaging our app and making it safe. And all of this is with programmatic code in Python. So now we're going to deploy the server. We're going to do basically the same thing that we did with the app, except it's going to be, the Docker file is going to be a little different because we're using Fast API. That's a Python server. But we're going to basically build a container for that. Now, we already deployed that EKS, which is the app. When we do CDK deploy EKS server stack, that's going to create that one on the right, and that's a new server. So now, because they're all within the same VPC, within the same cluster IP, the server can talk to the app, and there's a secure link, but the server doesn't need to be exposed to the internet. We're going to need the app to be exposed to the internet, because like users are going to go to the IP address or the URL, but the server needs to stay locked, so only the app can talk to it. So it's a great way to just use CDK to lock down your infrastructure and your networking without needing to be a networking wizard. Now, is our users' data secure? So a lot of logging doesn't happen with vibe-coded apps. And this is why, if you build on AWS, you can have things like CloudWatch, CloudTrail, and EventBridge that can help you track what's happening for your users around the clock. So let's say that a user used the app, they're using the API, they want to get some data from DynamoDB. We can actually start seeing that happen in AWS in real time, which is really helpful because then you get visibility across how your users are using your app. Now, if we want to do containerized RAG, which is what we're doing, that's retrieval augmented generation, that's how you can talk with your documents. The user will talk to the client. We're going to authenticate. We're going to talk to the API. We're going to talk to the DynamoDB database. We're going to get some data about the file, some metadata, some information. And then we also can use API Gateway. That can be connected to our Fast API server so that we can do streaming. And that then is going to link up to the Amazon Bedrock knowledge base, and that in turn is connected to our Amazon OpenSearch service vector store. So that's going to store all the vector embeddings for each file as it gets uploaded. Now, to deploy the vector store, we're going to create our own OpenSearch stack. You don't need to write all this down, but this is just like what the stack kind of looks like. We're going to do CDK deploy OpenSearch stack. then we're going to do the next one, which is the Bedrock knowledge base stack. So we're going to do CDK, deploy, knowledge base stack. And then once this becomes the input of that, we can then deploy our architecture. So one of the things that's also just like a little catch-22 is that when users upload files, this is kind of like what's going to happen. So you're going to authenticate, hit the API, we're going to talk to the server, and then we're going to do pre-signed URL strategy so that it's securely uploaded to S3. Now, to sync the knowledge base, we're going to need to use EventBridge, and that's going to basically say if you update, so basically like if you upload or write a file to S3, kick off this EventBridge, we're going to use this Lambda function, and that's going to be basically doing an ingestion job to then go to the knowledge base and then update OpenSearch service. So this is something that you can create, and that will work just synchronously as things are working, but just something to look out for to make sure that your knowledge base is synced up with how your users are updating their files. So we need to make sure that these files are also safe and not going to harm our platform and our users. So if a user uploads a file, we don't really know like if that file is cool. What if there's a virus in it? That could then basically infect your whole server. That could infect other users. Because let's say that you upload a file, and then other users use that file in their workloads or something like that. Well, now they're infected. So you need to think about that and not cause any issues. Because just because it's a file uploaded to the cloud doesn't mean it's safe. So the way that we're going to do this is that we're going to upload this. You can use a Lambda function, but in my build, I was using my EKS server, so either way. But then you'll get a pre-signed URL back. That will then go up to S3, and that's just the upload bucket. That's going to kick off a job to Amazon GuardDuty malware protection for S3. That's going to determine if it's safe, and then it'll be copied over to the production bucket. If it's not safe, it's going to get deleted. It's going to then be quarantined, and then that would also give us alerts to our system to let us know what's going on. So also, are we tracking how our users use our application? So if you have users that have unfederated access to APIs or any sort of other services or something like that, it can cause a lot of issues. Now, why this becomes important is there's sort of an attack vector called denial of wallet. So where that becomes is that it could be one user, it could be many users, but that user could ram your client. Now they're using your app like their own LLM of choice, and now you're basically footing the bill for their own AI generations. So that's why you need to think about this of like, how do you make sure users can't invoke too many things? So two solutions here. One is track tokens. Super easy way to just track the generations of tokens. You say like, oh, you only have 10,000 tokens a day or something like that. But you can just make a function. Like, it doesn't have to be that complicated. But it's really important with cost tracking so that users just can't exploit your system. The other part is rate limits. So that's another thing where if you just say like any time that they hit the API, just count up one. And then you say like, oh, they only have like 100 requests a day or something like that, or 1,000 or something like that. So automating the security process. One last component to just productionize this, we can use Amazon Q, kind of like what we learned about before, but Amazon Q developer in the PR process. So we'll set up Amazon Q. When you push to GitHub like that, that's going to kick off a webhook. IAM is going to hit Amazon Q, and then we're going to get back a response. So what that's going to look like is you add Q to your repository, and then you get these AI-generated code reviews, which is pretty cool. And then also, if there's issues with certain checks, Amazon Q could actually take action on that if you wanted to, or just alert you that something's wrong. So we just went through a lot of stuff. This is kind of like a speed run in productionizing an application. But there's a lot of stuff to get through in only 20 minutes. So what does this mean? Our productionized app is ready for production. It kind of looks a lot like what the app was before. However, our checklist now checks out. We have all of these green check marks as opposed to the kind of scary questions that we had at the beginning of the talk. And that's the thing where you can be rest assured knowing that your software that you deploy actually is deterministically and perpetually secure and safe. You'll, of course, need to keep updating it over time. But these are things where like I love seeing green check marks. I don't know about you, but like I love seeing checks go and tests. And that's something where now we have RBAC. We have strong scaling design. We have zero trust architecture. And we know and we can validate this. We also have authentication and authorization enforcement and logging, all the good stuff we want. And malware protection. We can scan our code. We have all these great parts of our application. So the productionized playbook is these 10 steps. You only really need to think about these 10 things, and then you can make sure that your application is scalable and that it's secure. And if anybody asks you, you have a whole list of notes to actually validate that you did what you're supposed to do. So If you want to build this, I have 3 different repositories in this one repo. It's like a monolith. So there's the CDK, there's the Fast API server, and then there is the Next.js application. I highly encourage you to check this out so that you can start building your own AI applications. And it was really fun to build. This was like probably the most complicated build like I've ever done. So it was really fun. Like I learned a lot, and I'm sure you will too. And if you have any feedback on it, I'd love to hear it. So thank you again for coming to my talk, and I hope you are excited to build.